Hello, algebra students. Mrs. Silva almost made a huge mistake. I was ready to send you the Chapter 10 extra credit for the other school, which isn't nearly as challenging. I was like, why is everybody having trouble with this one? And then I was looking, I'm like, 'cause they got the hard problems. That's why. So let me run through these. And no, they won't be any more difficult than these. Probably more in the other direction, slightly easier. All right. But you do have to read things super careful. Okay, class, when you're doing this. And I am going to give you the permutation and combination formula, but you got to know how to use it when and where. I'm seeing a lot of people not really using it. So make sure you look at that's in 10.8. All right, so let's start off here. Use this line graph to identify the period that saw the greatest change. Okay, that's the first thing you got to make sure you know. Are you looking for up or down? So when you look at these, and you can look at the decline from here to here, that's a decline. That's not an increase at all. Or the greatest change, actually, it could have been either direction. But look at this one right here. I can already tell that's going to be it. This is slight. This is almost non-existent. So I'm going to go with this range right here. And when I look down there, it's 2002 to 2003. All right. Use this data to make a graph. Explain why you chose that graph. Well, I'm hoping that you saw that there were years. And so whenever we're going to show a progression of something over years, a line graph is a great option. So we're going to go ahead and do that. I'm going to do University of Texas fall enrollment. Make sure you label your graph, make it look nice. I'll put the years down here. Is it in order? Yep. So we'll go 1999, 2000, and since they're exactly 1 year apart, we want to make sure our dashes are 1 year apart, or not 1 year apart, the same distance apart. And now we got to look at the range here because we got male and female. So I'm going to put number of students, but it's important to put in thousands. Oopsie, I'm off the camera. Sorry about that, guys. Because it says in thousands here, so we want to do that here as well. Okay, let's see, lowest here, so it goes 59 to 78. Okay, so I'm going to start at 0, but I'm going to go all the way up to, looks like about 100. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Wow, that was talent, I tell you. Talent. Pure talent. All right. All right, now we're going to do a line graph. So we're going to start, I'm going to put my key over here, and this is going to be males. It's going to be my red. Okay, because I have to have a key. There's two sets of data. So it's going to be a double line graph. So 59, so it's about right there. And 2000, they went to 71. Connect them right away. And then they went to 74. And then to 78. Okay. And I'll use this for my female. It starts with 80, goes to 83, goes to 86. Kind of getting shanky up here because I'm near the top there. I wasn't quite so perfect. And 91. Okay. So there's the two things. I've got my key to clarify the difference, and now I just need to answer the question because it also did say there's lines for a reason there. Explain. So the reason is because it shows the changes over time. Something about time. All right, so we're going to go up to the next thing, which, as you would have noticed, hopefully, is that it asks for a stem and leaf plot, but they give you two teams. So this is a double stem and leaf plot class. It's not two separate stem and leaf plots. So the stem is, of course, it's still in the middle, but you're going to have two leaves. The tree's got two different branches here. We got leaves on this side and leaves on this side. Okay, you can write the actual name instead of leaves. That's a better idea, actually. So I'm going to put 49ers over here, and I'm going to put Raiders over here. All right, so now let's look at the beginning. Remember, when there's one digit, you should go in front of those one digits and put a 0 so that you don't forget that that is the stem. So we've got 0, 1s, 2s. I see 3s in the front, and that looks like it's about it. I don't see any 40s. Okay, so 0, 1s, 2s, and 3s. Now I'm going to start with the Raiders. I'm going to start with this side. Okay, and when I look in there looking for zeros, the only one I have is the one that was actually 0. So I'll put a 0, 0. And 1s. So cross that one off. Got a 19, a 14, and a 14. So 4, 4, and 9. Wait, whoopsie, I missed the 3. 3, 4, 4, and 9. And then the 2s, I've got 2 7s, so we list both of them. And the 1s we only have, the 3s we only have the 1. Okay, now we're going to go to the left, and I'm going to write it I'm going to write it this direction. Okay, so I'm looking, there's only one, and it's 0, 3. So I write it this way, 0, 3. Now I'm looking for ones that start with a 1. 3, 7, 4, and 4. So the smallest was the 3, 4, 4, and 7. So you still go in increasing order, but it's going out this direction. 2. Wait, let's cross those off. 2, we got a 1 and a 6. So we put them in increasing order there. And we've got the 30. Okay, so then I again want to have my key there, so I can pick any number I want. And I'm going to put that one there so that we understand this, but you also have to have one here so that we understand the other side. So I hope that clears that up. I noticed a few of you had that one wrong. Feel free to re-listen to that. Now this one goes all the way through 4 to 7. Okay, and 7 actually is the next page, but I added that whisker plot. That was 7 on the bottom. So you're using all this data over and over and over again. So first of all, the frequency. Before I do frequency, I'm going to put them all in order because I see down here I need to have mean, median, and mode. So I'm going to list these off in increasing order down here, and then that will help me here anyway. So let's see, we've got a 15.2, 16.9. I already have them written down, so I'm just copying off my sheet here. Oopsie. Looks better when they're all in a long line, but it is what it is. So let's make sure I had 2, 4, 6, 8, 10, 12, 14 numbers. I was just counting them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, I just like to count them and make sure I didn't miss any. So now when we're looking for the frequency of 15 to 17.9, that's like right there. So I can just add them up. There's 2 of them. I can either do that for 2 things, or if you write the number 2, that's fine as well. And then we got 18 to 20.9. So where's 20.9 would fall right there. So we got 1, 2, 3, 4 of them in there. Either way is fine. And then we go 21 to 23.9. So that would be the cutoff. We got 3 in there. And the next one's 24 to 26.9. There's only that 1 in there. And 27 all the way up to 29.9. 1, 2, 3, 4. All right, we got to make the histogram now. Remember, histograms are next to each other. They share a side. So I'm going to do miles per gallon for vehicles. Okay, frequency over here. And oh, I got to put my little ranges. They gave them to up here, so that helps. That's helpful. 15 to 17.9, 18 to 20.9, 21 to 23.9, 24 to 26.9, 27 to 29.9. Now with frequency, it goes all the way up to 4, so we only have to go up to 4 equally. 1, 2, 3, and 4. And this is the miles per gallon, just making sure everything is labeled. All right, so we're going to shoot it up 2 for the first one. The second one we share a side, and it goes up to 4. The next one's 3. The next one is 1. Last one is 4. Okay, I always like to shade them in a little bit, but you don't have to. And voila, we are done with that. Now, when you did the mean, okay, you should have added these all up very carefully with your calculator. And then how many did we say there was? 2, 4, 6, 8, 10, 12, 14. Divided it by 14. And you should have gotten 21.9 to the nearest tenth. Make sure you read your test carefully. The median is the middle number. Okay, so I'm going to actually get rid of these slashes I put on here, so that doesn't get us confused. So the median is the middle number. So I'm going to start with both sides here and kind of cross off. So we got this one, and then I'm going to count in 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I'm going to keep going. 1, 2, 1, 2. Uh-oh, the middle is right here. You can double check. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, because there was 14, right? So the middle is not going to be a perfect number. You only get a perfect number right in the middle when it's an odd. So you need to take the average of those two. So you grab your calculator and we do 21.1 divided by 21.1 plus 21.5 divided by 2 is 21.3. And I am hoping some of you saw that all by yourselves, because 21.1 and 21.5, if you think of what's in between them, it's 21.3, isn't it? So I trust there was many of you that saw that. So there's my median. Mode is the one that appears the most. And if I look through here, it's the 18. There's 3 18s, and there's nothing else that are 3. If there was another one that was also 3, I'd put both down. Okay? Now, the whisker plot. So you're going to have a spot on the test where there's going to be the 5 spots for the numbers. Okay? Remember the boundaries. 15.2 is the outside one. 29 is the last one. The median that you just got, the middle, is the middle one. So you already have 3 of them done. Now to get this other one, you need to find the median between these 2 numbers. Okay, so we are going to start counting here. So we start with our hand on those numbers, and then we count. 1, 2, 3. Wait, is that right? Hang on a second. Starting here. Okay. Okay. 2, 3. Okay, there we go. So this would be we're not. This isn't one of the numbers. So I mean, it's a median, but it's not one of your numbers. So you're going to start here. 1, 2, 3, and this is the middle. Let's try that again on the other one in case you were confused. I'm not going to start on that number because that wasn't the actual median. Okay, my hand's in the way here. Whoops, that is too bright. Let's see here. Sorry about this. So we're going to start with the 21.5 and the 29. And we're counting in. So 21 I'm sorry. Let me see if I can manage this with it while you can actually see it here. Okay, so we're starting with these. So not this one, counting toward each other. This one, and the middle. Okay, so you're crossing them off. You cross off, boom, boom, gone. Boom, boom, gone. Cross them off in pairs, boom, boom, gone. And we're left with that one. Same thing here. Boom, boom, gone. Boom, boom, gone. Boom, boom, gone. And we're left with 27.2. Now, if this one was actually one of the numbers, you would have started with that number because you have to start counting in with one of the numbers. All right, so let's put it on a plot. So we got to go 15.2 all the way up. So I'm going to just have the 15 all the way up to, what does it go up to? 29. I'll do 17, 19. You'll have more room than this on the test. 21, 23, 25, 27, and 29. So 15.2, you put a dot. 29, you put a dot. The other three are lines. So 18 is a line. And I'm not connecting it to this line, by the way. This is just floating above it. 21.3 is a line. And 27.2 is a line. And then this makes one big box right here. You connect the whiskers. Go over that with the pencil. That's how it should look. Okay, so I hope that was helpful to you. Hang on one second. I feel like somebody's about to blast in here. Okay, I'm back. All right, so let's take a look at the back side here. I love these problems. Number 7, the probability of picking a red marble from a bag is 1 out of 9. What are the odds in favor of picking a red marble? So when you read this and they give you a probability, you should label this top number. What is that the probability of? You have a chance of picking what? A red marble. You have a 1 chance. Okay? There must be a total of 9 chances there, and 1 chance of them that it's going to be red. But now see here, this was the probability, and we're asking for the odds. So odds are always written with the colon. Okay, and it depends what they say here. What are the odds in favor of picking a red marble? Well, good. So that is the 1. Okay. Now it's odds. So you have 1 chance that you're going to get a red. How many chances? If there were a total of 9 chances, how many chances are there that you're going to get something that's not red? 8, right? Because these two numbers have to add up to 9. These are your chances for both situations. Now, what if I would have said, what are the odds against picking a red? Well, that would have been flipped. It would have been 8 to 1. So whatever the odds are of doing whatever they tell you to do here, that's your first number. And then the other one is the other one. All right. Marissa surveys 4 classmates about their favorite restaurant. 3 classmates answer Mr. Burger. Oh, not Mr. McBurger. And 1 answered Salad Stop. Explain why the following statement is misleading. Miss McBurger is the favorite restaurant of a majority of students. So the problem there is the size of the sample, isn't it? They picked 4 classmates. Okay, so you can't, the sample size, so I'd write something like this. The sample size is too small to be able to represent the whole class. They're saying a majority of students. It's just way too small. You need more of a sample than that. All right, down here, the rolling. Notice this is for questions 9 and 10. So make sure you're reading. And we're rolling a number cube, or die. And it gives you the outcome and the frequency. Okay, so remember, the outcome is the chances that you roll a 1. Frequency means that's how many times they got the 1. 24 times. Okay, because they did an experiment. There's experimental probability. And the number 2 they got 10 times. The number 3 they got 8. The number 4 they got 3. The number 5 they got 30. And the number 6 they got 15 times. So what is the experimental probability of not rolling a 6? Okay, well, first my question to you is, well, how many rolls did they do? Because that's the bottom. Remember, in probability, you got to have the total in the bottom. How do we get the total amount of rolls? That's right. Add up this frequency. This is how many rolls they did. So you would add those all up. 24 plus 10 plus 8 plus 3 plus 30 plus 15. And guess what you get? 90. That's the bottom. That's our total. Now we want the probability of not rolling a 6. So that means it could have been a 1, a 2, a 3, a 4, or a 5. Okay, so you can add up everything here but the 6. Or another way to look at it is you could have taken the total and taken that 15 away. Okay, either way you do it, you get 75 times they rolled and got something that was not a 6. Now let's reduce that. I can see there's a common factor of 15 there. And if you can be reduced, I would like you to reduce them down. All right, the next one. James rolls the number cube 250 times. Predict. So now we're using the information you figured out up here and predict the number of times it will land on an odd number. Okay. Well, first of all, we need to get the probability it would land on an odd number. So when we go up here, we still had the 90, did we not? But how many now were odd? Okay, up here it asked how many were not 6, but I'm asking how many were odd. Okay, so that would be this one, and this one. So let's add those up. 24 plus 8 plus 30. What is that? Right, 62. Okay, let's simplify that down. I know for sure you can divide them each by 2. Get 31 over 45. I think that's it. But now okay, so that's the probability that you would get an odd number, right? The number of odds over the total. But now they're trying to predict, okay, well, what if you were going to roll 250 times? Okay, I don't want to roll. We only rolled 90 here. So what you can do is all you have to do is take that probability and multiply it by 250. So we can do 31 times 250 equals divided by 45. And it comes out to a decimal. And what could we give for an approximate answer? How many times? Not going to round it to the nearest tenth because we don't roll die for a tenth of a time, do we? I'm going to do it to the nearest whole number. So that is approximately 172 times. Okay, again, listen to these over again if you need extra help with these. All right. Find the probability of randomly choosing a vowel. Put this down a little bit. Maybe that'll help that lightness there. Okay, theoretical. So now there's no experiment. They're just saying if you're going to randomly choose a vowel from the letters in this word, okay, what would that probability be? Okay, well, first you need your total. Total what? Well, total letters. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, they said of choosing what? What are we looking for? We're looking for a vowel. How many vowels are there? 1, 2, 3, and 4. Can 4/10 be reduced? Because I don't see 4/10. Well, right, it can be reduced. You divide by 2, and you get 2/5. So the answer is C. All right, here we go again with odds. Love the odds. The odds against picking a red marble from a bag are 4 to 3. Okay, what is the probability of picking a red marble? Okay, remember, let's figure out what's representing what. We got a 4 and we got a 3. What is the 4 representing? Let's see. The odds against picking a red marble. Okay, so not red. I'm going to just put that right with my 4. Not red. So that must mean the 3 represents red. So what's the probability of picking a red marble? Class, how many total are there? How many total? Because I just want to go back to this one for a minute up here. Remember, when you do a probability, the bottom is the total. And when we broke it up, the odds, the two odds together add up to that total. So now when I come back over here, I can figure out that bottom number by looking at the odds. What is it? 4 plus 3 is 7. Okay. The top number is going to be the 4 or the 3. You just have to read the question to figure out which one it is. What is the probability of picking a red? So the answer would be the 3. Done. All right, moving on. This is probably one of the tougher ones, I would say. 2 number cubes are rolled 3 times in a row. What's the probability of rolling a sum of 9 all 3 times? Well, first of all, when you roll them, and you're going to roll them again, those are all independent events. So there are 3 different probabilities. You are going to multiply them together. Okay, so let's just get that right out there. Now, figuring out the probability of each, they're actually going to be the same because they didn't say different events. They said of rolling the sum of 9. But we need to figure out the bottom of these fractions, don't we? So that means when you roll the die, how many different possibilities are there? And I can't remember the page now. I helped somebody with this today, and I can't remember the page. There is a page in your book towards the end of the last, like 10.7 maybe, or 10.6. And it lists all the different possibilities that you could get for 2 die. But I will just tell you, it's 36. Okay, there's a total of 6 possibilities. 6 on one and 6 on the other. 6 times 6 is 36. So our total in all of these is 36. But now, how many possibilities are there of getting a sum of 9? Remember, sum means to add. Okay, so think of the way you could put 2 die together to get 9. So you could do 6 and 3, right? What was that up to 9? But I could do 3 and 6 too. And you got to count in both directions. What else? 4 and 5? And 5 and 4? Anything else? So how many possibilities are there? 1, 2, 3, and 4. Simplify them. 4 is 30 over 36. You can divide those both by 4, and that reduces to 1/9. They all will simplify to 1/9. And you're left with 1 times 1 times 1, which is 1, over 9 times 9 times 9, which is 729. Odds aren't real hot to do that, are they? You got a pretty slim chance of getting that. All right. The kitchen drawer contains 8 forks, 8 spoons, 6 knives. Jordan randomly picks 2 utensils without replacing the first. What's the probability that he is going to get 2 forks? Okay, so he is going to pick 2 items. So we got 2 probabilities. Okay. We have to figure out the total. So what's the total total number of utensils? 8 plus 8 plus 6 is what, class? 22. Very good. Now I'm not going to put that on the Why did I put it under there? I usually put it in the middle here. My two numbers I'm multiplying. I'm not going to put that here because I noticed that it's without replacing. So once they pick one out, it's not going back in. So let's just start with the first one. If I have 22 and they want to know if you can get 2 forks, how many of them are forks? 8. Okay, so that's the first probability. I have a chance of 8 out of 22 of pulling a fork. But when he keeps that fork out now, class. So now how many do I have to pick from? I don't have 8 forks anymore. Now I have 7 forks and 8 spoons and 6 knives. So I only have 21 things in there now. And if I'm looking for, again, a fork, because it says 2 forks, I'm looking for a fork again, how many forks are left? 7. So we're going to simplify and multiply. 7 over 21, you can divide those both by 7. Get 1/3. 8 over 22, you can divide them both by 2. And get 4 over 11. Why do I do that? Because I don't need to use a calculator then and get big numbers. 4 and try to simplify it later. 4 times 1 is 4. 11 times 3 is 33. Done. All right, and the last two, these are super, super, super important. Okay, because I'm going to see if there's a better way to do this. If I turn that light off. I don't know. All right. It says from 12 prepared songs, a band chooses 3 to perform on a TV show. 1 song will be played at the beginning, 1 in the middle, and 1 at the end. Tell how many different set lists are possible. Then tell if the situation involves permutations or combinations. Okay, again, there's 2 different things for permutations and combinations. I'm going to give you the formulas. Okay, so I'm actually going to put them right here. Hang on one sec. Okay, so let's see if I can put one down here. Permutations, combinations. So this is what I'll give you. Okay, that's what you can expect to see for the test. Now you need to know how to use that, don't you? And you need to know when to use it. The P stands for permutation. This is combination. And one of them, the order matters. And so let's go back to our problem and talk about that. In 15, the order matters because they're saying one's going to be played at the beginning and one's in the middle and one's in the end. And they want to know how many different set lists are possible. So that's implying that they could use the same 3 songs and rearrange it differently, and it would count as another whole way. Okay? So that is a permutation because the order matters. Okay? So order matters. So we're going to do how many of them? 12 and 3. Now when you do this, look at the permutation down here. Let's move that a little bit. I think I can fit this. I may not. There we go. I don't know what my problem is here. Anyway. There. This. Ah, okay. Sorry. Okay, so order matters. We're going to use permutations. Now, I put the number in front that the total, and I put the smaller number that I'm going to pick out second. So this is my n, and this is my p. N factorial. Okay, that's 12 factorial over n minus r factorial. So that means you just subtract these two. 9 factorial. And as I showed you in the video, you are going to continue to decrease this until you get to 9. So 12 times 11, that looks like a 19, that's an 11, times 10 times 9 factorial over 9 factorial. Now, hopefully you watch the video, because the reason we do that is I don't want to write 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Nor do I want to write 9 times 8 times 7 times 6 times 7, blah, 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 only to cross them all off. Okay, so when I see the 9 on the bottom, I go until I see the 9 on the top, and I cross those off, because those will all cancel and equal 1. So all I have left now is to multiply 12 times 11 times 10. And we get 1320. So kudos to you that got that right. And don't forget your second part. There was that, tell me if it's a permutation or combination. So make sure you don't miss that. Now, number 16, let's see what that is. A race has 8 runners and awards them in first and second place. How many different ways? So would order matter there? Heck yeah. You think you think the second place the first place one wouldn't mind being second? Of course they would. One option is to have the same 2 runners, first and second, or flip them. So the order does matter. So it is, again, a permutation. I hope that didn't trick you guys. So we have 8 in how many places? There's 2. So it's going to be 8p2. And now we're going to complete it the same way. So we have 8 factorial over those subtracted. So 8 minus 2 is 6 factorial. I'm going to do the top until I get to the 6. So those can cross off. And I'm left with 56 ways. So let's just take 2 seconds here, and I have my book here, hang on. Let me grab a combination one, because I want to make sure you have to be able to do both. So just hang tight for 1 second. Let me see if I can find one quickly. Okay, there's 11 different cereals, and yeah, okay, so here we go. Let me get a piece of paper. I'm in my son's room. Let me steal a piece of paper out of his notebook. All right, so let's do a combination. Let's say I'm going to the store. And there are 30 cereals in the aisle. 30 sweet, yummy cereals in the aisle. And Mrs. Sullivan never gets them for her kids, but she told them, hey, you can each pick one. Okay? So we are picking 3 out of there. So it's not going to matter the order. And they're all going to pick 3 different ones. Okay, so it's not going to matter the order. How many different ways can you get 30? How many different things? And it's not going to matter the order of them. So I can have Cocoa Puffs and Sugared Rice Krispies, or whatever they're called, and Trix is the same as if I said Trix, Sugar Rice Krispies, and Cocoa Puffs. Is that what I said? So the order does not matter. So that is a combination. So you got 30, and you're choosing 3. Now, just to remind you, the formula was that. Okay, so let's do it. So I'm going to get the n factorial. That's the big number. So 30 factorial over. The only thing different, you actually subtract these. And the only thing different is that now we also have this factorial. That's it. Otherwise, without that, it's the same as a permutation. Okay. So I'm still going to take that top number, though. I'm going to leave that and do the 30 times 29 times 28 times 27 factorial, because that's my big number. I'm going to rewrite it down here. But you can't forget the 3 factorial. I'm going to write that one out. 3 times 2 times 1. Okay, so these are gone. Praise God. And now I got to simplify. So the 3 and the 30, divide them each by 3, and we get 10. 2 and 28 will simplify. Divide them each by 2, and we get that. Oh, wowie, mama, we're going to have a lot of options here. So we have 10 times 29 times 14. I feel like I didn't mark. Is that right? 142. Yep, I got 4,060 ways that I could get those 3 different cereals. All right. Too bad they're not getting them. Anyway, so there you go. Class, study. Okay, you know what's going to be on there now. If you can understand these different concepts for this, remember, you can print off the extra credit again and try it again. Really. We're narrowing down now. We got this and we have 2 more chapters and that's it. So these tests are super important to some of you. So put the time in now and good luck. God bless y'all. Bye-bye.